Hello. Hello, everybody. Good afternoon. It's great to be here again. And before we start, I'd like to say we brought some T-shirts that are left from yesterday. So if you tweet a picture and hashtag JavaDay 2016 and tag me or Burr on Twitter, we have, I think, 10 T-shirts left. So you have to hurry a bit, but not right now, just after the session, OK? So now I'm going to present effective and clean Java code tips and tricks for the real world. I've been a software consultant and developer for like almost 20 years. It might sound much, but I'm not that old. Okay, I've just been doing code for a long time, and I've collected just a great set of tips and tricks for developing mainly Java EE applications. I'll try to share some of these tips for you today. I'm a director of developer experience at Red Hat. My Twitter handle is @Yanaga. I'm also a Java champion and a Microsoft MVP. But I think the best definition that I have for what I believe is that I believe I'm a software craftsman. And a software craftsman is someone that cares about this job, somebody that believes the software can change the world and can change people's lives for the better. And I believe software is a craft different from being a fabric, because we never do the same software twice. And if we could do, if we were paid to do the same software twice, I'm pretty sure all of us would do the same software differently, because we would have learned a different process, different techniques. We would have applied some knowledge, different knowledge on that to produce a different software. So even if we were given the same requirements twice, on the second time we would do and create and craft a better software. So I believe that our job is much more like somebody that creates like a violin or something else, because you spend a lot of time producing that beautiful piece of art. You spend some time of your life, your job, you choose the best techniques, the best tools that are available for you, just to create something that represents something for somebody. And in your case, software can represent a lot of things to a lot of people, because software can scale very easily, different from creating a violin or a piano. So software can be easily reproduced and can benefit much more people than some other kinds of crafts. I also believe this software development is an art. I have this beautiful quote from Donald Knuth, which is a kind of famous person in the computer science world. And I took this quote from the Museum of Computer History from Palo Alto. It's a very nice place to visit. But computer programming is an art because it applies accumulated knowledge to the world, because it requires skill and ingenuity, and especially because it produces objects of beauty. So I guess that for many of us that are developers, there's nothing more beautiful than seeing a very specially crafted code to solve a real world problem. Because basically we're problem solvers, and I guess that for a software craftsman, how you solve the problem and how is the state of your code is as much important as making the code work. So making the code work, maybe it's not enough. Maybe we can do better. Maybe we can produce these pieces of art, not because we want to make it beautiful, or maybe because we want to brag about it, but because it's very useful for software maintenance to craft better code. Because, you know, I guess 90% of our jobs is not creating new code, but maintaining an existing one. So we can be much more productive, and we can make much more difference in the world if we can just deliver features faster, deliver better software faster. And for that, we must keep our code in a certain level of quality. And I'll try to introduce you to some techniques on how you can create these beautiful types of work. And maybe some people believe that creating beautiful code is just a waste of time, a waste of money, or a waste of life. But in the end, I like this quote from Jordan Apello, the guy from Management 3.0. No matter what other methods you apply to achieve competence in a social system, and software is a social system, in the end, it all depends on whether people actually care. So you might be taught a lot of different techniques and lessons and everything else. But in the end, if you're going to make better software, it all depends on if you care about what you're doing. So just as I care about the software that I do, I hope that you are able to believe that you can do better software and that you can change people's lives for the better with the software that you craft. And I have to say to you that I've learned a lot in like 20 years developing Java software. And in some moments of my life, I have been one of these arrogant bastards just because I have learned a lot. I have a lot of experience. I just found that other people were just producing crappy code and was blaming and cheating them for doing that. Then I just realized that it's not helpful to others to just be criticizing and blaming others, because you can't blame someone for doing something wrong because he haven't learned the way to do it right. So instead of just blaming other people for not producing code with the quality that I expected, I decided I would do a much better job for me from the other people if I could just help them to create better code. So that's something that I decided a few years ago, and that's why I'm here today, to try to share to you some of the techniques. I hope that everything that I show you today is useful. I have a lot of different experience that I've collected in the past few years, and I hope I'll be able to show you something in the few minutes that I have today. I usually do some workshops using these techniques, but today I'm going to try to show you everything that I can do in 50 minutes. So instead of just talking about what can we do, let's try to do some code. So I'll do a live code demo, and it's always challenging. So some things might break and go wrong, but you know, it's a live demo. So let's take my IDE. I'm gonna mirror that. And you bet. Now I have an empty code. So let's start with some discussion. I'll try to use some JPA models. I've chosen this subject for today. I'm going to show you how we can properly encapsulate some domain model classes. So we've been talking about domain-driven design for about 10 years, but I believe that most of the software developers still aren't aware of domain-driven design, or at least they don't know how to apply that. And maybe that's because the Eric Evans book about domain-driven design is a very good book. You read it, you just get eager to start using domain-driven design techniques, but then you sit down and try to write some code using domain-driven design. Oh my God, I have no idea how to apply that things in my code. So I had this feeling too. It took me like 6 years to know how to code some of these techniques in code, and it's a pity that we don't have another book trying to show these techniques. Maybe someday. So I'll try to code some of these things. So in domain-driven design, usually we have some things. I'll try to use only the concepts of entities, value objects, and aggregates. So when we have a domain-driven design, I'll call entity. So we have an order system. Maybe we have a customer. Maybe we have an order. Maybe we have the items of the order. Maybe we have products. Maybe we have a value. Maybe we have amount. Maybe we have an order number and everything else. So all of these things are part of our domain model, but clearly they behave differently in our system. So I'd like to give you some definitions. Entity in domain-driven design terminology. Entity is something that has an entity on its own. And it doesn't matter if its attributes change over time. It's always that entity. So for example, a person. I have a name, I have a date of birth, I have a sex, I have an address, I have a phone number. So even if my sex changes or my date of birth was typed incorrectly, it changes over time. If my address changes or if my phone number changes, I'm still the same person, so I still have the same identity. So that's the concept of entity. And value objects are the things that are only meaningful by its value, so it doesn't have an identity. So you have a phone number with number 222, and you have another phone number with 2222. If you compare one to each other, they're the same. So I can replace one phone number with the other phone number with the same value, so it doesn't mean anything different in my system. So value objects, in case our terminology, means like expandable objects. You can create a value object, you can replace a value object with another one with the same value, and it simply doesn't matter for you. Okay? So that's the concept of value objects. And aggregates means that for proper encapsulation of my domain model, you can see over time you realize that some classes, they used to change together, and some classes, they are used to change apart. So you try to collect all of the entities that change together into another entity, which is usually a bigger one, and we call that an aggregate. And this aggregate is the thing that usually manipulates internally other entities, but you simply do not expose these internal entities to other clients of your code. So the only thing that external clients of your code see is just this aggregate. So that's the basic concept that I would like to tell you. But let's start with the simple. So an entity, usually it behaves, and we want to persist an entity because it represents a state. And if this state varies over time, usually it's beautifully mapped in a JPA entity. So let's try to do this mapping. I've chosen one simple use case. Usually I do some, I ask people to choose the domain model to be doing, but just because I'm in Ukraine and I don't know the domain model that you used to, I just use a plain old order. It's a plain simple example, but I hope to be able to show you some beautiful showcase. So that's an entity. So if that's a JPA entity, I have to tag it entity. It has to implement serializable. Also, it needs an ID. I'm going to get an ID. Generated value, and maybe it needs a number, so I'll give it an integer number. So here we start the first discussion. I'm using just primitive types for my model, and why is that bad? Because order number, the number here is just an integer, but I could assign that a zero value. Maybe it's not meaningful to my domain model. Maybe I could assign a negative value, which is also not meaningful. But I allow that because my type integer allows it to be anything between minus something and then plus something. So I want to restrict that. At least order number must be only positive numbers. What should I do? And the order number, if I have order number 12 and another 12 for order number, I can exchange the values, and it doesn't matter for me in my domain model. So number, maybe it's the perfect candidate for a value object. And how do I create domain objects that are useful for me? Domain objects, value objects in domain-driven design, by default, they are immutable. So how can I create an immutable class to be used in JPA? So let's create, instead of just create an integer, let's create another class called order number. And by creating this class, order number, usually it has to be serializable by the JPA. And it will have an internal representation of an integer, but nobody has to know that because it's just internal. It's also final because it has to be immutable. Once it's final, I have to create a constructor to initialize this value. So let's create a constructor. But I really don't like constructors. I think it's one of the things that could be better in the Java language. But fortunately, we have a lot of years of experience. Any of you that have written clean code and affects Java, you already know some of these tips and tricks. So instead of using constructors, my favorite way of creating new objects is a factory method. And luckily for us, many of our RDEs today already have this refactoring. So just refactor here and replace constructor with factory method. And my choice is to create an of method. So instead of creating new order number, I'm just create a order number dot of, and I'm going to pass the value. It's going to create it for me. And why is that useful instead of using a new? Particularly, I think it's the syntax is clear. And also, it has another benefit because Java has covariance in return method types. Instead of just returning an order number, I can return also any subclass of order number. So today, I only have order number as a class, but maybe I can create another kind of order number tomorrow, or maybe I can create a whole hierarchy of classes from order number, depending on the value of the integer that I pass to the class. So I can change my code, and only one method in my code. I can change it here. It will change the type that is returning as long as it extends order number. And my system will continue to behave correctly, and I won't have to change anywhere else in my code. So the only point that is responsible for creating order numbers is this method, and I can do some very interesting checks. Also, a best practice for coding. Sometimes we assign null values. Null pointer exception is by far the most recurrent exception in our word. So instead of allowing null values, I can use some very useful libraries, just like Guava, which is an open source library, initially contributed by Google. So I can just check not null value. So if anything goes wrong, if anybody passes a null value for creating my order number, the null pointer exception will rise here when I'm creating my object instead of when I'm using my object. So it's much more helpful for me to know what the source of the problem of the null pointer exception instead of later when I'm using that. So that's one way to do defensive programming. So I don't allow null values. And I also have to check if the integer value is greater than 0. So I have to check the argument that I received. So value must be greater than 0. Just using auto boxing and unboxing here. And if I can successfully create an order number object, I guess that it's not null. And it is also a positive number. So that's two of the checks that I can do just using order number. Also, for value objects to behave correctly in my system, I have to, in this case of Java, I have to implement equals and hash code. And today, my favorite way of implementing this kind is if object instance of order number. You can implement, return. Thankfully for us in Java 8, we have objects class, objects.equal, this dot value, other dot value. Oops, it doesn't recognize other because I haven't typed that. And who is order number? Other receives object. OK, and then return false. That's my favorite implementation of equals today. And hash code. Thankfully, we also have object.equals, this dot value. Oops, not equals, hash. OK? So we have order number. Also, it's very useful to implement toString methods in classes. We also have on Guava another helper class to implement toString. And what is the purpose of toString? toString usually is not used to represent something to be printed to the user, but toString is very useful for you to be debugging your code. So you'll be using the login statements to know what information is being passed in your system. So toString methods, I like to format them to be very useful to show the information when I'm debugging my code, or at least seeing the log statements. So I can use a class from Guava to more objects, toString helper. I can pass this, then I can pass the parameters that I want. In particular, I'm going to add the value here and toString. Okay, that's one way of using toString. But what if I want to show this information to the end user so they can show in the screen and behave it correctly? So there's another interface in Java that you can use, and it's pretty old. So the correct interface for you to implement if you want to format information to be shown to the user is not, you don't override toString for that. Use the formattable interface, which is pretty old. So I'm going to implement this method format2. But basically, what you do, you get the formatter, and you print what you want. So format2, basically, I'm printing a number, and I'm going to pass the value here. So it's a very simple way to be doing this kind of information. Some of the benefits that you can use using formattable, and it automatically gets the locale, the format of the data, the format of the currency. So you can use all of the benefits, which has been available in java.u2 for a long time. It's already built in formattable, but it's impressive that has been available for 15 years, and very few people still use formattable. So formattable is for strings, formatting strings that are shown to the user, and you can internationalize things too, because formattable is compatible with the Java internationalization features. So that's some of the ways for you to do that's a proper formatted and crafted value object for that. And now we have order. But you see, now I have order number perfect in my JPA identity, but JPA doesn't know how to store order number in the database. So I have to tell that. Before JPA 2.1, we have to rely on provider-specific implementations. Like who uses Hibernate as a JPA implementation? Okay, most of you. Hibernate has had user types for a long time, since version 1 or 2 or something. But since the JPA 2.1, we have another way, a standard default way in JPA to be using these conversions. So instead of creating a Hibernate user type, I can use a JPA attribute converter. So I'm going to create an order number attribute converter. Another class, it just has to implement attribute converter from order number and the type that I want to store in my database. In this case, can be an integer. So I'm going to use an integer. Then I have to implement these methods, which is basically convert to database and convert to entity attribute. And I have to check if it's not null. It'll return null. Else I can do a safe check, order number, return order number. I could be returning, sorry, attribute.value, but you guess value is a private information for my class. Two ways of solving that. Since they're in the same package, I wouldn't break encapsulation if I just got the order number and removed the private. Now it's package private, and it's still accessible inside the package. I won't be breaking encapsulation, but some people don't like to be using direct reference to attributes of classes. So maybe you want to use create a method for that. So another way of solving this problem is you create a method here. Some people would argue that I could use a get value. I don't like a get value method because it just exposes a value. Usually represents the internal value of the object. If I'm using get value, I'm showing to external code that I'm using an integer as an internal implementation. So rather than using get value, I prefer, if I'm going to do that, to integer. So I give no clue of what is the internal representation of my class. So if we're going to use create a method, let's create at least to integer. And instead of attribute to integer. And here the same, instead of just returning null, if dbData equals to null, I can return null. Else I can return order number dot of dbData. Okay, that's a properly created converter. So I can converter auto apply true. So it will be automatically mapped to all of the order number instance in any entity that I use in JPA. So that's one way of mapping your value objects to your database. So let's keep our example. I have order. Now I have order number. Of course, I don't allow any order in my systems to be created with a null order number. So I have, again, I have to create a constructor for that. Only number. And again, I don't like the fact of using constructors. So I'm going to use a factory method. Okay. Factory method, mainly because I also believe that constructor logic code, I could do the check-ins in this case inside the constructors, but again, it's much more flexible to be using in a factory method. I put the check-ins here, and again, of is polymorphic, and constructor code is not polymorphic. So that's, if you need just one reason, that's because factory methods are polymorphic, and Java has covariance. And again, I can check not null, number, and it's not going to allow me to create an order with a no number. Okay, then I have to expose it. I get ID, get number. One way to generate beautiful, effective, and clean Java code is to minimize mutability, because some people argue that mutability is the source of all evil in our production code, because crafting code is easy. The hard part in any system is the state of your application evolves over time, and usually you don't have control of who is changing the state of your entities over time. That's where usually where the bug rises. So when you try to minimize the mutability of your entities in your codes, you also minimize the bugs that you can have in production. So usually you have to minimize that, and I usually don't allow classes to have setters to change the state of the code. But also I know that most of the frameworks that we use today, particularly any Java framework that use getter, Java beans and specifications, getter and setters to modify properties, they will be using getter and setters. So instead of, but maybe order number can be changed after order is created, so it's safe to just get a getter. But if you have a customer, you have a name, and you have something else, a date of birth that you have to change over time because somebody typed it incorrectly, then I choose to be pragmatic instead of being dogmatic, because being dogmatic usually doesn't help a lot. It's much better to solve problems in the real world. So if your framework requires you to use getter and setters, then just accept it and allow some some exceptions to your rules in domain-driven design, and just create a setter for that. It's much better to resolve problems than just to try to fight against something that is already built in. So even in the domain-driven design book, there we have a best practice there, which is don't fight the framework. So if you're using a framework you have chosen to do so, just don't fight the framework. Just accept the benefits and the liabilities that the framework brings to you. So we're going to get here a number. Then the next thing, an order usually has items. So I'm going to create another class which is order item. An order item, what does an order item have? It has to be serializable. Also, maybe it has a product. I'm going to use product as a string because I won't have time to implement it. I'm going to, maybe it has an amount, a quantity. Can be an integer. And maybe also it has a value. Can be a big decimal. Okay. Also, I already have the properties, and I'm going to map that to an order. The first thing that people would do, will create a list, which can be like order item, items. I create a list. I have a default implementation. Never allow collections to be null. And many of the people would just create a one-to-many relationship, and then map a many to one inside the order item. I'm saying that's a bad idea because it doesn't matter for you for the items. The only useful information in the item is that you have a product, a quantity, and a value, and if you have another item with the same product, same quantity, and same value, they are the same. It doesn't matter if you replace one object for the other. So clearly they are not entities, but rather they are value objects, and we should implement them so. Luckily for us too, since JPA 2.0, we are able to map value objects in our JPA projects. We don't have to map these as an entity. It won't be useful for us because entity, you can't just replace one for the other. You have some problems with JPA today. So it's clearly not an entity, and then an entity requires an ID, and you don't want an ID for a value object. We want it to be expandable. So the right way of mapping value object to a JPA entity is to map them in an embeddable, and instead of using that one-to-many mapping, luckily, since JPA 2.0, we have element collection. So now we're mapping a list of value objects in our entity, which is order, and they're all expandable. You can change them. And the only thing that maintains the state of this relationship is the list. So you don't have these things that the strong side of the relationship, weak side of the relationship. Usually you would have to have a reference to the order here in the order item. It doesn't matter anymore because it's just a value object. So it's much more easier to implement. You don't get this lazy initialization exceptions too because element collections usually are eagerly fetched. So you have all of these benefits just by using order and order item. So that's the right way of mapping, so we're going to get better later. And now, if I have to expose the items, many people would do that too. Get items and just return the plain old list. So why is this bad? We need to minimize mutability. When I return the list this way, I'm allowing any kind of code in my application to change the list of items. People can exchange the items. People can create a new one. People can add order items from order. Okay, and exchange one for that, and now we have a wrong domain model. So it's not safe to do this. So you never allow external clients of your code to be modifying the list, the collection inside your code. So you have to return something that is immutable. And luckily for us, Guava has immutable lists. Items. Now your code is immutable. Nobody can modify your list except for your own class. So if you're doing that, you also need to create some methods to modify your internal list. So I'm going to do that later. Now I'm going to get back to order item. So let's see. That's a value object. The domain-driven design requires my order item to be final. In fact, immutable. To be immutable in Java, I have to declare final. But final doesn't match quite right JPA. I can declare fields as final. I have some problems. So I won't be declaring final because JPA specification limits me. Again, don't fight the framework. So instead of just, but I can assure that it's immutable by not allowing external clients to change the state after the object is created. So we're going to create a constructor here. And again, I don't like constructors, so you create a factory method. Here, check not null product, static. I can check not null quantity, check not null value, and again I could use a checker argument, quantity must be greater than 0, and everything else. I can do a lot of checks, and I'll put my business logic checks here when I'm creating an item, instead of just using some validators or something else, some business logic later in the interface. I can do everything here. I can just check the exception that is raised if anything goes wrong. So I have just a routine. If you're creating a validator later, the only thing that you need to check is to try to create the object, and if anything, if it raises an exception, you know that the value that you're passing to your system is wrong. So I have here, this class also needs a beautiful implemented equals and hash code. I won't be implementing right now, but you know I had the example because it's going to take me too much time. I have lots of things to show. So here, it could be implemented using formattable too. ToString would be used for debugging. You should be implementing that, but I won't be here be doing right now for time purposes. And you don't allow it to modify it, and the only methods that you're allowing your class to have are the getter ones. So you can create just the getters, and so I have get product, get quantity, and get value. So that's my beautiful value object for order item, and I can just replace. Now, how do I manipulate the items inside my order? I'm going to create an adder method because I just want to add things. Maybe we could be creating a remove or replace. So public void add item, maybe. Then an order item. And I even could check if my items doesn't contain the item that I'm adding. I can add it again. You see? So the only point in my code that allows my list of items to be modified is this adder method. And you see I can add some beautiful logic here. It's much more easier to maintain because the logic that I have today, I can't put a duplicate element in my list of items. But maybe somebody requested me, if I'm just adding an item and they have the same product and they have the same product, instead of just not allowing it to be added, I want you to take the amounts and values, maintain the value, the lowest value or biggest value, doesn't matter, and just add the quantities. You see? If you would do that without encapsulation, you would have to be searching in your code all of the points in your code that are trying to modify and add items to the order. You would have to dig and search, and mostly likely it would be duplicated code, and mostly likely, of course, you would forget some places, and it would lead to bugs in production. But this way that you did, the only place that you have to modify is that if the item already contains the item, instead of just adding, you would replace the item. You would remove the current item that you have on the list and create a new one with the same product, with the added quantities, and with the same value, for example. Okay? And then also, in this case, even the definition of equals of our order item, previously I could have implemented here order item. The equals method could compare if the product, if the quantity, and if the value are the same. That's my definition of equals. But then the business requirement of, instead of just not allowing to add the quantities of the order item, created a new definition of equals for me. Now for me, two items are equal if the products are the same. So I would change that to definition of equals. So my method here would behave differently. Contains for me would mean contains the same product, and I would be able to implement the logic of adding the quantities just here, which I won't implement. It's just plain simple logic, but it's perfectly here. And the only place that you would have to change anything in your code is right here inside the adder method. So you had another benefit of doing that. So it's pretty useful. You can see that encapsulating your domain code is very much useful for you. You can do that with just very simple techniques to be able for you to solve this kind of problems. So what else I can do here? Maybe later, somebody requests that I want to show in my beautiful interface the order. I want to show the total amount of the total quantity of items that the order has. So I have to show it in the screen. So the obvious reason I would implement order.getItems that I iterate it over with a for, or maybe I'll be using Stream API to have this amount. But in any piece of my code that require the total quantity of the items, it would be duplicated, so I'm smart. So I'm not be doing that in duplicating code. I'll create a getter method here, and I would name it public integer get total quantity. Implement that, so I'm smart, and so I want to use the Stream API, so I'm going to solve this problem very quickly. Okay, that's just for you to be able to brag to your colleagues that you can use Java 8 streams, and I'm pretty sure you had a lot of sessions at this conference using streams. So I want to get an item, I want to map that order item, I want to get the quantity. So now that I get the quantity, I want to sum all of them, I want to reduce it. It starts with 0. Can use just 0 and integer sum. Okay. Now I have the total quantities. I'll just sum it up everything. I'm returning it. But then another question rises. Maybe I just don't want the total quantity. Now I want the total amount of the items. Then I'll create another method here. Public big decimal get total amount. So I'm just trying to create some problems that I'm going to be able to solve later. I'm going to map here order item, get value, total value. Sorry, get value, and then reduce. I start with 0, and then the big decimal add. Okay, then I'm just getting the total value, but then some business requirement came, and now I not only have a list of items, but I also have a list of discounted items. Okay, so I'm adding here. You would have to create another entity if you would not be using value objects for the mapping. But now it's not only order item. I also have a list of private list order item again, discounted items. Okay, and it's also an element collection. Okay, you can specify here also as a collection table the name of the table that you want to save and everything else. I'm just using the default values. Okay, so you could be using it's very flexible. You can map it with JPA the way that you want, and it works. I have many systems delivered into production this way. So now you don't have just items, you have discounted items, and you want the same logic because you want total amount, you want the total value, you want the total quantity. Now you have a name clash. Oh, dear God! And then I'm going to be smart again and just copy paste everything. Yeah, very beautiful solution. I'm just copy paste here again, and instead of total quantity, total quantity of what? Total discounted. Get discounted. You see how beautiful it becomes? And that's just because I have two methods for manipulating my listings internally. Now I have two, but I duplicated. Now I would have 4. Imagine if I had like 5 or 6 methods inside my items. I will have to duplicate all of them, so it doesn't seem much smart. We can solve that problem too. In domain-driven design, in JPA and everything else, nobody told us that we need to expose our implementation saying it's just a plain old list. And luckily for us, Guava also has some of the default implementations for us to solve this problem. So instead of just using lists or immutable lists or plain old lists, I'm going to create another class, which in case I'll call it order items. But of course, you can name that the way that you want. I just don't want you to name it order item list, because then you're implying that it is a list, and maybe later you want to change that as a set. Okay, so order items, and I'm going to stand forwarding list of order item. Okay, and I'm going to implement serializable. So what I have to implement methods delegate. I'm going to have an internal order item delegate. and return delegate. So it's just a wrapper. I'm going to wrap another list of order item inside the this order items class. So I also, again, I don't like constructors. I'm going to create a constructor and create a factor methods. Refactor factor method of. Now I have to check if it's not null. Okay, then return check not null. Okay, then it's okay. It's a delegate. It's just a wrapper for another list. It doesn't do anything for now. But now that I have a class, maybe it's better instead of just duplicating the code that I have here, which is just like total quantity, discounted total quality. Let's just remove this method from here and create it inside the order item class. So because the quantity is who is the owner of the property? Total quantity, this is a property that belongs to the collection of items of my order. So maybe if I just put in another class, in this case order items, it would be much easier for me to solve this problem. So I can just use delegate here. I could also be using here if I go to the order again and get value. I come back here to order items. I can put here, instead of delegate, instead of total value, I just get value. So I have this implementation and order. Now I can just remove the remaining methods. You see? And my order, oh, not here, sorry. No, here, yeah. I implemented, did I implement? So order items and order class. Okay. Now I can just remove all of the code here. You see, and maybe I'm using a big font. My order is a class that still fits in my screen. So instead of just returning a list of order item here, I'm going to return order items, okay, which is still a list because implements list. And instead of returning immutable list.copyof, I'm going to order items of items. And if I get discounted items, instead of be returning the direct list, I'm going to be returning order of discounted items. Okay, which is still a list, but I'm going to change the return type here. Order items again. And if I get to test, I'm going to create a very quick test. Order test, okay. If I get to order number of 1, order, then my code just becomes ordered get items, get quantity. And if I want to check the quantity, discounted items quantity, I just guess order discounted items dot quantity, because now I'm just adding behavior to a class that used to be dumb. Now my code is much clearer because I'm calling get quantity in the correct order items object. So it's much easier for me to maintain code because I'm creating more classes. Each one of them is trying to behave correctly according to the single responsibility pattern. So we have much more classes that are immutable by default, that have some behavior. We are trying to create a rich domain model instead of just a poor one. And that's what I want to show in order items. So last, I just have 5 minutes, so I'm going to try to show a last thing. I have order, and maybe I have many different kinds of operation that I want to apply in my items, and I don't want to break my encapsulation. So I could be using add discount, add taxes, add something directly into my order class, but then you can see my order class would become bulky because it would become huge. Then maybe we can try to specialize that. I'm going to create another interface here, which is order item operation. And thanks to Java 8, I can extend, sorry, that's an interface. I can extend a function from one order item to the another order item. So it's just extends function import Java. Okay, I just create an operation and in order. If I want to manipulate the items internally, I would apply this. Apply then order item operation. Then we could do this mapping. Items, they receive, stream, map, operation, collect. Okay. So I'm going to replace all of the items because they are expandable, but I'm using a mapping operation to transform the items that I have to now. So how can I use this? I'm going to create, I love enums. I have a lot of tips and tricks about that, but I'm going to show you just one today, I guess. I can use order item operations, which needs to be an enum. Then it's going to implement order item operation. Okay, and I'm going to create a discount operation. Okay, it doesn't compile because I don't implement the method, so I'm going to extend it here using it. I'm going to implement the methods, apply. So I could be using that. I'll return a new item, which is just order item of item get product, item get quantity, and then I'm going to use a discount. I'm going to apply discount in another line. Item dot get value. I have to multiply it for big decimal. 0.9. Wait, I'm going to give 20% discount. Okay, so if I get this operation, and I'm going to get again to my code, order test. If I want to get this item and apply a discount in all of the items of 20%, everything that I need to do would be order, apply which operation, order item operations dot discount. Then all of my items would have discounted. So my code can be clear to use, can be concise, can be beautiful, can be encapsulated, can be immutable, and it's not that hard to do. It's just a very simple series of steps that you can apply every day to make your code even better. Okay, so and you don't have to do it all at once. I've been doing this for a long time, so for me now it's kind of natural. But you can apply each one of these techniques step by step just to improve your code, reducing mutability, creating immutable value objects, adding this kind of encapsulation, using these new beautiful features of Java 8. So it's all available to you right now for you to use. You just have to get these tips and get it done. Because, some other tips that I want to do, if you want to create more easily this immutable value objects, Immutables is a very interesting project. So far, it's one of my favorites for creating immutable values. You have Auto too from Google, which is good, but so far I think Immutable is better. Another beautiful library for using Java functional coding, Java 8, the Java 8 library has some beautiful APIs, but something is missing. So you had a session about Java Slang yesterday. It's a very good library for you to be using. It has some missing things from Java 8. It's very good for you. And the final message that I want to say is that software can change the world. Software can change people's lives for the better because software matters. And I know that you all know that this leads us to a great responsibility. That's why I almost died some years ago, 5 or 6 years ago. And I thought about what I was almost dying. I thought, which is my legacy? What are the good things that I'm leaving for the others? That's why I decided that it's not enough for me to just try to create beautiful code. And instead, I could be much more helpful to my friends, to my family, to the other people. If instead of just coding, I would be able to help others to create better code. That's why I'm trying to share to you some of these tips. And I'm pretty sure that you all have some tips and tricks that you can share to other people. So, knowledge and love are some of these rare things that when you share, in fact, you just multiply, so you can give it for free, and you won't be missing anything. Okay, so you have it all, and you can give the amount that you want because you never fall off knowledge and love. So that's what I would ask you to do too. Just as I'm trying to share some knowledge, so that you maybe can create and craft better code, so you can share with your friends, with your colleagues, so they can create better software to change their lives too for the better. That's what I wanted to tell you for now. As soon as I stop traveling and have some time, I'll try to post all of this material on developers.redhat.com. I would like some feedback if what you're using, what you're doing to create better code. My Twitter handle is @Yanaga, and thank you very much. Thank you very much.